will explain the nucleon numbers and how can we define isotopes, and we will look at the different isotopes of the atom. To start with, let's understand the structure of an atom. In an atom, we know that in the center we have nucleus and electrons are revolving around it. In the nucleus, we have protons and neutrons, which are collectively called as atomic mass, and atomic number is the number of protons which are present in an atom. And in a neutral atom, the number of protons are always equal to the number of electrons. Let's talk about the charges of these subatomic particles. Protons are positively charged, neutrons are neutral, and electrons are negatively charged. So as the number of proton and electron are equal, so the charges on them are also equal. That's why the atom is neutral as a whole, because the number of proton and number of electron are equal. So the number of the positive charge, or the magnitude of the positive charge on an atom, is equal to the magnitude of the negative charge. So they cancel out each other's effect and atom is neutral as a whole. Now let's consider this and understand this by taking the example of helium. In helium, the symbol is He, and we see two numbers written on the helium, 2 and 4. 2 is the atomic number, which is the number of proton, and 4 is the atomic mass. Atomic mass is defined as the sum of number of proton and neutron present in an atom. And if we know that there are 2 protons in the helium, that means 4 minus 2 are the number of neutrons in helium atom. Let's take another example. We have oxygen atom shown on the screen. On oxygen, we see 2 numbers, 8 and 16. 8 is the proton number, which is also called as atomic number, and 16 is the mass number, that is nucleon number. Mass number is equal to proton plus neutron. P stands for proton and N stands for neutron. Mass number is defined as the total number of proton and neutron in an atom. Everything is written on the screen, so you must be very clear about it, how you are going to define atomic number, how you will define what you are going to write for the definition of atomic mass. So this is all information shown on the screen. So we now see that in oxygen there are some atoms which have different number of neutrons. The number of proton is same, but they have different number of neutrons. Those atoms of oxygen are called as isotopes, because they have the same number of atoms but different atomic number, but different number of mass number or atomic mass, and mass number is different because they have different number of neutrons. So how do you define isotopes? Isotopes are the atoms of the same element which have the same number of proton but different number of neutron. So whenever in the CIE exam they are going to ask you what do you mean by the term isotope, you are going to exactly write this definition. Let's look at some examples of the isotopes. Here we take example of oxygen. In oxygen we see 3 isotopes. They have the same number of proton as 8, 8 and 8 is written as the proton number or atomic number of oxygen, and at the top we see the mass number, which is different on all the 3 isotopes of oxygen. The first isotope is having 16, the second is having 17, and the third one is having an atomic mass of 18. As we see that proton number is 8, so that means the number of protons stays same for all the 3 isotopes, but the number of neutron is different. If we subtract the mass number and proton number, we get 8, which is the proton number for the first isotope. If we look at the proton number of the second isotope, that is 17 minus 8, which makes 9, and the neutron number for the third isotope is 18 minus 8, 10. So if we look closely, we see that the neutron number for all the 3 isotopes are different, but the proton number is same. So let's go back to the definition of isotope and see if we understand the definition by looking at the example or not. Now you will understand the definition better, that isotopes are the atoms of the same element. See, we saw the 3 different atoms of the same element, oxygen, where they have the different number of neutrons but same number of protons. You can also write it this way, that atomic number is same and mass number is different, and then it is understood the number of neutron is different. Alright. So now let's look at how the properties of these three isotopes of oxygen are different from each other. We know that chemical properties of any atom depends upon its number of electron. As the number of protons are same and number of proton are always equal to number of electron in a neutral atom. So that means that chemical properties of all the three isotopes of oxygen will be same and the physical properties would be different. You must know that what are the physical properties? Which properties are called as physical properties? Think about it. Yes, physical properties include melting point, boiling point, solubility, density, its color, its shape. So these are under the physical properties. And what about the chemical properties? Chemical properties are actually the chemical reaction. What is its tendency to react with the other elements? As number of electrons are same, so chemical properties of all the isotopes of the same element will be same, as the physical properties are going to differ from each other. Let's look at another example of isotope carbon. Carbon has three isotopes. Carbon exists as three isotopes in the three isotopic forms: carbon 12, carbon 13 and carbon 14. Carbon 12 is having 6 proton. All of the three isotopes are having 6 proton, whereas the number of neutrons are different. For carbon 12, if you count 12 minus 6 will come 6. If you count for carbon 13, it's 13 minus 6 comes out to be 7, and 14 minus 6 comes out to be 8. So these three isotopes of carbon have the same proton number but different neutron number, and out of these three, 2 are stable and 1 is unstable. My next topic will explain that what is the relative atomic mass and how the isotopes are helping to calculate the relative atomic mass, or why in the periodic table we see some of the elements having the atomic mass in decimal. That's all for today. I'll see you in the next video. Thank you. God bless you. Allah Hafiz.